If an equation has multiple roots, or the same variable with one being inside of a root, move the variable expressions to opposite sides of the equal sign, then solve. So here we have an x in this radical, but we also have an x over here in this radical. So we put them on either side of the equation, and then in this case, we would square both sides because they're both the square root, and then we can solve. And then we just check our answer like we did before. Sometimes you might have multiple solutions to a radical equation. Try solving the problem below. Alright, so we have this radical isolated on this side, so let's square both sides. And that gives us x squared plus 8x plus 16 equals, so we're going to have x plus 4 squared, which is x squared plus 8x plus 16. So we have the same exact thing on both sides. So if we had simplified further, we would get to this point, x plus 4 equals x plus 4. When this occurs, your equation has infinitely many solutions under certain conditions due to the radical. Let's select some x values to substitute into the equation to see where the equation is true. We'll select the number required to make the equation equal 0 on both sides, which would be x equals negative 4 as our first value. Then we'll select two numbers above and two numbers below to see if we can determine the pattern. So we'll plug in x equals negative 4, and we get 0 equals 0, which is true. So two numbers above, so that would be negative 3 and negative 2, and those are both true as well. Then we pick two numbers below. So we pick two numbers below x equals negative 4, so that would be negative 5 and negative 6. And we see that when we plug those values in, they're both false. The x values that yielded a true statement were negative 4, negative 3, and negative 2. The x values that yielded a false statement were negative 5 and negative 6. Therefore, the final solution to our equation would be any value of x that is greater than or equal to negative 4, or written like this, x is greater than or equal to negative 4. Another way to determine the values of x that made the statement true would be to graph both equations in the same coordinate plane. So this here is the graph of the square root of x squared plus 8x plus 16, and over here we have the line y equals x plus 4. The graph shows that the two functions are equivalent when x is greater than or equal to negative 4. So from here on this way, we have both red and blue lines, and that's when they're equivalent. Here's an example. Alright, so let's undo this radical by squaring both sides. And instead of just writing squared here, I'm just going to rewrite it so that we can do FOIL. So over here, we just end up with x minus 1 because the square root is undone by the exponent. But on this side, we have FOIL. 3 times 3 is 9. 3 times negative square root of x is negative 3 times the square root of x. We have that same term again. And then we have plus, because we have two negatives, x, because the square root of x times the square root of x is x. Now we'll simplify, so we have x minus 1 equals 9 minus 6 times the square root of x plus x. And we can just subtract x from both sides, and that gets rid of these two x's. We still have this one here. Now we just want to isolate this term. So if we subtract 9 from both sides, we get negative 10 on the left. Then we have negative 6 times the square root of x over here. We will divide both sides by negative 6, and we get the square root of x equals 5 over 3. So now let's square both sides again to get rid of that square root, and we end up with x equals 25 over 9. On the next slide, we are going to check to see where this solution is true. Alright, so we get x equals 25 over 9, we plug that in, and we get 4 over 3 equals 4 over 3. So this solution works.